All right, gents, here we go. Another day, another integral. So we're going to talk a little bit about U substitution again. Talk a little bit about U substitution and maybe some more difficult problems. Now, I think they're more difficult in the sense that maybe you have to be a little clever or more clever, but I don't actually think they're that bad after you see one or two examples. So I'm going to do the first three for you, and you'll do the rest, okay? I'll do the first three, and you'll do the rest. And maybe I'll give you some hints on the rest. So, where do we start? We can start for this first guy. And what do we want to choose U to be? Well, we have a sine of 5t, we have a cosine of 5t, we got an e to some power. This looks like it could be kind of complicated. And I'm going to choose U to be equal sine of 5t. Now, why am I choosing that? Well, the derivative of sine is cosine. And I hope to be canceling that numerator out. So, if U is sine of 5t, du dt now, right, different variable, but not a big deal, is going to be, well, we need the chain rule, so it's 5 times the cosine of 5t from the chain rule. Okay? Which gives us that dt is equal to du over 5 cosine 5t. All right, now we can make our substitution. What do we get? Let me make a little line here so we have room. This is the antiderivative of the integral of cosine of 5t over e to the u, du over 5 cosine 5t. Right? And then we notice that, okay, we got a cosine here, got a cosine there. So the cosines cancel, and that 5 in the numerator we can pull out as 1/5. Integral of 1 over e to the u du, which is the integral 1/5 times the integral of e to the negative u du. Now you might be tempted just to simply pull that to do that integral, right? To do that integral without thinking too hard about it, but we don't know how to do the integral of e to the negative u. We only know how to do the integral of e to the u. And what's the trick we use if we don't know how to take an integral? We try U substitution. But we already did U substitution. So this would be a double U substitution, right? We need to use 2 U substitutions, right? And we can't use U again. We can't use U twice. So what would be the right letter to do a double U substitution with? A double U substitution? Well, W would be the right letter. W, we'll set W equal minus U, dW, du, and that du is because we're taking the derivative of a function which has u's in it. It's equal to -1. So du is equal to dW over -1. So we have here, this is the 1/5 times the integral e to the w dw over -1, which is -1/5, pulling that negative out, integral of e to the w dw, which is 1 over 5 e to the w plus c. W is minus u, so we substitute that back in, over 5 e to the minus u. U is 5 cosine sine of 5t. So this is 1 over 5 e to the negative sine of 5t. So let me take a moment, let you guys kind of stare at that. And you might notice, right, like it's tricky because there's two u substitutions. That is certainly tricky. But like both of them are pretty straightforward. You do the thing, you choose what your u is going to be, and if it works, great. In this case, it didn't, so we need to choose another substitution to make. Right, and after we make that other substitution, we can go all the way down, and then we can make our substitutions back in. So now, number 2. Let's do number 2. Number 2 is going to look kind of like something we did in class. Number 2, maybe I could do number 2 over here. When we have fractions, we like to let our denominator be u. So u is going to be 2x minus 3. Y is going to be 2x minus 3. U is going to be 2x minus 3, so du dx is equal to 2, which gives us that dx is du over 2. I can write the integral down, 5x plus 10 over u du over 2. So I can pull the 1/2 out, pull out the 1/2, integral of 5x plus 10 over u. I know this is a problem similar to class, but we need to be a little more careful. Why do I say that? Well, the one in class, it was really easy to see what x is supposed to be. Here we have to kind of solve for x. And if I do that here, I'm going to add 3 to both sides, then divide by 2. So x is equal to u plus 3 over 2. And I can make that substitution. So this is 1/2 of the, I forgot my du over here, of the integral of 5 times u plus 3 over 2 plus 10 over u du. All right? Which is then equal to, so what can I do with this 2 here? I can kind of pull it out. So this is 1/2 integral 5 over 2 times u plus 3 plus 10 over u du. All right? I can split this up into 2 different fractions. This is 1/2 integral 5 over 2 u plus 3 over u plus the integral of 10 over u. Both of these need a du. All right, so this one on the left, I can pull that 5 over 2 out. So this is 1 over 2 times 5 over 2 integral u plus 3 over u du plus, pull the 10 out, integral 1 over u du. So this last guy here we can say is 10 ln, absolute value of u plus c. And now this other one, we're going to need actually to do kind of the same trick again. So 1/2 times 5/2 is 5 over 4. Integral of u over u du plus integral of 3 over u du. And these are all in parentheses. 5 over 4. Integral u over u is 1, so the integral of u over u du is just going to be u I can pull the 3 out here, and I got 1 over u, so this is plus 3 ln of u plus 10 ln u plus c. Okay? Now, if we simplify a little, we get 5 over 4u plus 13 ln, absolute value of u, plus c. And then we just have to recall what our u was. U was 2x minus 3. So this is 5 over 4 times 2x minus 3 plus 13 ln, absolute value 2x minus 3, plus c. All right. Now, that was a lot. That was a lot. And that's kind of how these problems can get complicated. But you need to be aware of that. So, we have one more problem I want to do today. It's probably the most complicated of the ones I want to show you, but it still is based on some of the topics we've done already today. So it's just a little more complicated algebraically. But before we go on to that topic, I want to talk to you about the sponsor of today's video, Raid Shadow Legends, which is something you can do instead of doing math. Raid Shadow Legends. Back to the video. Number three. So we're running a little short on room over here. So I'm going to copy that and let's bring it down here. Bring it down here. And we're going to use the same trick we've used a couple times so far. We want to choose u to be our denominator. 7x minus 3. So if we skip a few steps, we get dx equals du over 7. And it's going to prove useful in a second, and you'll see why. But I'll just write x equals u plus 3 over 7 by simplifying. Okay? Now we'll substitute in. This is the integral of x cubed plus, well, yeah, we can write that first. X cubed plus 5x plus 6 over u times du over 7. So I can pull that 7 out. 1 over 7. And we have an integral of x squared plus 5x plus 6 over u du. Now we have the issue where we didn't get rid of all of the x's. So we need to use that substitution that I came up with before. So let's do that. Let's do that substitution. We will substitute in u equals 7, x equals u plus 3 over 7. So this is 1 over 7 integral x plus 3 over 7 squared, u plus 3 over 7 squared, plus 5 times u plus 3 over 7 plus 6 over u. Okay? And now we can do a similar trick to what we did before. This is 1 over 7. Then we have the integral of u plus 3 over 7 squared over u du plus integral of 5 times u plus 3 over 7 over u du plus integral of 6 over u du. Little complicated, but we're okay so far. And this 1 over 7 is multiplied by everything. So we got 1 over 7. Integral of. I need to square that thing out. So I need to use the distributive property. If I do it, the distributive property to the top, I'm going to get u squared plus 6u plus 9. Do it to the bottom, I get 49. And if you remember, a fraction over a fraction, this is 49u du. This u comes up into there. Plus, again, we use the distributive property, 5 times u plus 15 over 7u du. And we can actually calculate the integral of 6 over u du. The 6 comes out in front, 1 over u, that's ln u plus c. Okay. All right, so now for each of these, so I got that 1 over 7 out in front. I can pull from this guy that 49 out in the denominator, 1 over 49. And I can split this up into 3. So this will be u squared over u du plus 6u over u du integral plus 9 over u du integral. All right, so that's this first guy. Plus the second guy, I could pull the 7 out. 7 times the integral of 5u over u plus 15 over u plus integral du du. Then we have, all right, plus 6 ln absolute value of u plus c. All right, and now we have all these integrals to take. So we got 1 over 7 times 1 over 49 times, if you remember, so we simplify these two. U squared over u is just u. The integral of u is u squared over 2. Over here, u over u cancel, so this is just the integral of 6. The integral of 6 is plus 6u. And then the integral of 9 over u is plus 9 ln of u. And there's that guy. Similarly, 5u over u, those two u's will just cancel, right? We get the integral of 5. Integral of 5 is just 5u. Then we got 15 over here, so it's plus 15 ln of u. Then we got plus 6 ln of u plus c. And we just need to plug u back in. U, if you remember, I don't, with 7x minus 3. So we plug u back in. So we get 1 over 7 times 1 over 49 times, I already forgot it, 7x minus 3. 7x minus 3 squared over 2 plus 6 times 7x minus 3 plus 9 ln 7x minus 3 plus 7 times 5 7x minus 3 plus 15 ln 7x minus 3, ran out of room, plus 6 ln 7x minus 3 plus c. And there's our antiderivative. We can simplify it more, but I don't really want to. And I'm sure you don't either. But this is as complicated as it can get. Would I ever ask you a question like this again on an exam? No. Would I ever ask you a question like this ever again? Well, yeah, there's one that looks like it in number 8, maybe even a little more complicated. But you'll be all right. You'll be all right. Let me give you some hints for these. Number 4 and number 5 are both double U substitutions. Okay, for your first U in number 4, I would try the 3 theta. Okay, the 3 theta. Similarly, and then I guess for your second U, I would try the sine. Just sine, not sine to the 4th, just sine for your second U. So your double U. We can make that sine. Similarly, in the next problem, your first U, I probably want 2x. And then for your second U, I would suggest just tangent, not tangent to the 5th, just tangent. Okay? Number 6 has got a typo in it. I just want x plus 1 over x minus 1. And number 7 and number 8 are okay. So, thanks for watching. Thanks to our sponsor. And if you have questions, feel free to reach out. Take it easy.